Thank you, thank you. So again, my name is Josh Phillips, and I'm a program manager on the parallel computing platform here at Microsoft. And on the parallel computing platform, we're working on a number of different technologies, some of which are shipping in Visual Studio 2010, like parallel extensions, and some incubation technologies as well. One of which we're calling Axum, which in a sentence, and this goes great with all these adjectives that you love for languages, is a safer, scalable, more productive parallel programming language for .NET that really builds upon the principles of isolation, message passing, and actors. So I'm going to give you a little bit of a caveat here. We just recently had to change the name. It used to be called Maestro. So if I slip a few times and you're like, what the hell is he talking about? It's this. So 15 minutes, not a whole lot of time to cover a lot. I'm going to talk quickly about what the value propositions are, why we're even incubating a language. That's obviously an important step for Microsoft. And give an overview of the main concepts of Axum. There's a lot of other concepts that I'm just not going to cover at all. We just don't have the time for. But there's other information I can point you to. And a little bit about why we're incubating and why that's important for you to know. So I'm a mushy guy, and I like to be motivated by inspirational quotes. So I'm going to throw some up there. And Professor Ed Lee at University of California, Berkeley said, if the state of your entire universe can change from one instant to the next, there's something wrong with your universe. And that's a pretty good statement. I agree with that. He also said, programmers are asked to take a wildly non-deterministic model and rein it in where needed. We should start with a deterministic model and add non-determinism where necessary. Now, who can argue with that? Right? So Axum exists to take care of some of these issues. So here are the value props. First and foremost, anybody that's done parallel programming knows that shared state is the devil, that it's evil. And I say that kind of tongue-in-cheek because, unfortunately, as the F# guys know, in any practical scenario with real-world applications, it's a necessary evil, right? And I'm sure there's debate in this room about that.
Shared mutable state is the devil. Right. Shared immutable state is fine.
Right. And so, and actually, my next point was that shared state inherently is not evil itself. It's what you do with it. It's the bad things that it causes in your code that's evil. I have thread A that's accessing or writing to shared state X, and I have thread B that's reading from shared state X. And when I designed the application, I never intended for those two things to happen simultaneously. And even in my test labs, it never occurred. But when it was out in some random guy's machine, a year later, it popped up, right? So we want to get rid of those. And what we can do is we can get rid of the implicit dependencies, so the ones that you didn't intend to happen. And then where you actually need the dependencies, whether it be for performance or for some other reason, we'll make it explicit. So you're opting out of, it's opt into shared state. So again, because it's necessary for practical applications, when we have to deal with shared state, we want to make it a little bit easier. Typically today, what do? You use some sort of mutual exclusion lock or reader-writer lock, and effectively it sort of takes care of the serialization problem, but it has a whole host of other problems, and it's difficult to use. So we want to make it easier. We want to give you a declarative model for dealing with shared state. So we want you to declare how you intend to use shared state and let the runtime take care of the actual serialization for you. I think that's important. Finally, we want to provide an application model that's inherently concurrent and responsive. So we look at the tools today and the languages that we use, like C# and VB and C++, and someone had mentioned that on the website they say that they're multi-threaded and laughed at it. And well, we laugh at that too, right? Because they weren't really built for that. We're built in a time where, if we wanted to increase the perf of our application, we would wait 18 months and get a faster chip. And I'm sure you're all sick of hearing the whole, the free lunch is over, go freak out kind of thing. But it's sort of evident, in my dual-core laptop and the 4-core machines that we have, the 4-core laptops, that these giant monsters that we haul around in the offices over at Parallel Computing. It's sort of evident that is kind of true. So what are some things that we can do to make it more inherently concurrent and responsive? Well, let's make everything concurrent by default. Now this sort of ties back to this, where ideally we'd like to eliminate all shared state if possible. So where that is the case, we'll turn everything on by default, and we'll allow you to opt out of it and serialize where you need to serialize. Also, let's leverage latencies. So we know that computers are these machines that have multiple components that are all doing different tasks concurrently at different rates, and there's this mismatch of timing, and there's all this sort of latent parallelism. So let's fill those waiting periods with meaningful work. Cool. So Jason will love this slide. So Axum from 50,000 50,000 feet, right? So I'm just kidding. This last four, it's not special purpose, concurrency-oriented, cancer-solving-oriented, or dynamic. It is imperative, though. It feels imperative. So I talked about some declarative parts, but we wanted it to feel like C#. We didn't want you to have to take a whole new syntax style. And some of the syntax is weird, and we're working out the kinks. This is incubation. And it's actor-oriented, so that's important. So we're not talking about objects as the primary concept anymore. And in fact, you can't even define objects in Axum, which is sort of plays to this bullet here. It's object-aware rather than object-oriented. And that also plays into the fact that it's special purpose. So we don't intend for Axum to be the general purpose programming language that C# is. You're going to define objects and types in another language like VB or C#, and then you can use Maestro to coordinate and get safe concurrency out of it. Axum, thank you. See? This is a really difficult transition for me. It took me like a day to make all the changes. So I love this cheesy slide. It's just like, it's awesome. So these are the 5 main concepts in Axum / Maestro. And I wanted to put them all together so you can kind of just sort of tie the concepts together in your mind, and then I'll dive into each of them. So there's this thing called a domain, which is really like a house. There's some resources in there. It has 4 walls that protect these resources. There are agents or people that sort of act on these resources, do things with them. Agents like to communicate to each other, obviously, and they use channels, which could be like named mailboxes. These are all concepts that you're familiar with from past languages. I mean, there's nothing new here, right? And then when we talk to other agents, we may not really know who they are. We may not know how they talk, so we want to know how we can talk to them successfully. We also want to know what we can talk to them about. So that's where schemas and patterns come in. So domain. Domain is a passive construct. This is really what's sort of putting isolation around my shared state, right? So state can be shared by 2 agents within a domain, but not shared by an agent in a different domain. So this is a code sample here. This domain A has some state J, and this domain B has some state M. There's also a function. In Axum, functions are truly pure functions, methods, update state. So important to differentiate. And I can see that X and Y can do nothing with M, and Z can do nothing with X and Y. They have to go through one of the agents to do that. So an agent, it's a thread of control. That's really what it is. It's a thread. It communicates with other agents, whether intradomain or interdomain. This is where the reader-writer declaration comes in. And in fact, this code sample is exactly the same. The only thing I've added are these 2 modifiers here, so writer and reader. And then this agent that doesn't have a modifier is a no-access agent. So a reader can read to J, but not write. You'll get a compiler error if you try to write. A writer can write, and no access can do nothing with the state. So the other interesting thing about this is that this actually defines sort of how things are scheduled, right? A writer has exclusive access to domain states, so no 2 writers can execute at the same time within a given domain. As many instances of a reader as you have, they can all execute concurrently, which is great. And the nice thing about having 2 domains is that any agent in domain B can execute concurrently with any agent in domain A. So it's important how granular you make your domains. So much like interfaces are proxies to classes in C#, channels are like proxies to agents, and they look pretty similar actually. And actually, when you define an agent, you say : whatever ch addition. We do define a little bit of additional modifiers for direction. So these are duplex channels. And the cool thing about channels, the important thing about channels, is that there's no shared state that can be leaked from a channel and thus a domain, right? It has to be a copy. So you're all saying, I've seen this before. It's called Erlang. Pattern, again, this is how we do the talking. It's really just a state machine. There's some special states start and end. I have a channel which is, like I said, a collection of ports is how they communicate. I can use port A and then use port B, and then I can use C, or I can go back in a loop. Once I get to C, I have to end. So this is a standardized protocol between 2 agents and how to talk over a channel. Schema is the what. It just has the fields and some rules on the fields. Things can be required or optional. There can be functions. They have to be pure functions, of course. And it's serializable, so it can be transferred over the wire. In fact, I don't have a slide on this, but we just recently put in WCF host providers for agents. So you get this very nice model that extends from the core to the cluster. So this is, how am I doing on time? Oh, good. This is what a Axum application might look like, right? I'm sorry, this says domain, but anyway, this is a big domain. There's 2 domains in this application. They each have their own shared state and some number of writer and reader agents. In this case, I have 3 writer agents, which of course can only execute mutually exclusively, and reader agents, which can execute concurrently with each other. I talk, the protocol tells me the how I can talk to another writer, or I'm sorry, to another agent, and the schema tells me what I can talk about. That's sort of the overall picture. So why are we incubating? Is language the better way to go? So I'm assuming that most of the people in here are language geeks, if they're here. But at Microsoft, we don't always think the best idea is to just throw a language at a problem, right? So there are certain aspects of why we feel the language is a better way to go, and we're trying that out. So incubation is important. Are we actually reducing complexity? We're requiring a shift in thinking. We're adding concepts. Are these costs amortized by the benefits that you get, right? Are you getting productivity gains? Are you getting scalability gains? A lot of feedback that our customers give me is, I want to be able to take my junior level programmers and throw them at concurrency problems, and they can't because it's too hard to think that way. So when you're within an agent, it's easy to think because nothing is affecting you. You're single threaded. Legacy, can we migrate some legacy apps over to Axum? And most importantly, are we building it right? Are the syntax and semantics right? I talked about Erlang. We have lots of people that love Erlang, lots of people that love the concepts in Erlang but hate the syntax. I hear that a lot. Are we missing any concepts? Are we making people more productive? Is it a good platform fit? So that's it. That's my and our call to action is go out to the blog. We still have, unfortunately, this name there. We can't change the link. We'll go out to the blog and read up on it. I'm really hoping that we can release something soon. We've been working hard for that, but I can't give you any dates, of course. But look at the blog and see when it comes out so you can play with the bits and give us feedback. We really, really need the feedback. I mean, feedback is what's going to make or break us and get us funding. If you have any questions, unfortunately, I have to run because I need to be somewhere. So I can't stay for a lot of questions. I can stay briefly. But you can always email me at phillips.joshua@microsoft.com.